Everything you do in terms of subnetting, subnet masking, and IP addressing revolves around binary and decimal conversion. You must, and I'm going to repeat this throughout the module, you must know this like the back of your hand. The good news is that it's actually a lot easier than you might think. Before we get started, get out a pen and a piece of paper if you want to follow along. There are really only two things you need to remember to convert between decimal and binary. Just two numbers, the number 8 and the number 128. The number 8 represents 8 places. An IPv4 address is divided into 8-bit chunks called octets. Each bit can be a 1 or a 0. Here we have all bits set to 1. So what about the other number, 128? Well, look at the leftmost place. Its place value is 128. In other words, a 1 in this place equals 128 in decimal. Now, for every bit that you move to the right, the place value is exactly half of the one directly to the left. So the next one over to the right would be 64, because 64 is half of 128. What would the next one be? Well, half of 64 is 32. See the pattern here? Based on this, you can calculate the place values of all the bits. Moving to the right, the values would be 16, then 8, then 4, 2, and finally 1. Okay, so what do we do with this? How do we use this to convert binary to decimal? Well, to convert binary to decimal, all you have to do is add up all the place values for each bit that is set to 1. Let's look at an example. Here we have a binary number, all ones. The first thing we need to do is mark the place values like so. Next, we look at each bit that is set to 1, and we add up the place value for each one of those bits. So since all the bits are set to 1, we do 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which of course equals 255. By the way, in the exam you will have a scratch pad that you can write on, so practice doing this on paper. Try to do it in your head if you can, but always check your work. Let's try another example. 1111100. Write out all the place values for each bit that's set to 1 and then add them all up. 128 plus 64 plus 32 plus 16 plus 8 is 248. Now notice here, I did not write out all the place values, just the ones that I added up. As you get more practice doing this, you won't even need to write out the place values. You'll just remember them. All right, let's try one more example. This one's a little bit trickier. 11001101. Write down all the place values where the bit is set to 1 and add them together. The answer is 205 decimal. Okay, I don't want to bore you with any more examples, so let's look at the reverse. What if we want to convert a decimal number to binary? Let's say we need to convert 139 to binary. Well, think of the binary place values, 128, 64, 32, and so on. The first thing we do is ask, what is the largest place value less than or equal to 139? Well, that would be 128. It's less than 139, and there's no place values larger than 128. So we would put 1 in the 128's place. Essentially, we're creating the binary number bit by bit, and by setting the bit in the 1's place to 1, this binary number you see now is equal to decimal 128. Now don't worry if you're still not sure exactly what we're doing. As we continue, you'll see the pattern start to emerge. So now we have to fill in the rest of the places. So what do? The original number we're trying to convert is 139, and we placed a 1 bit in the 128's place. So what we need to do now is subtract 128 from 139, which will give us 11. Now we need to ask another question. What is the largest place value less than or equal to 11? Well, it's going to be 8. 64, 32, and 16 are all bigger than 11. 8 is the highest value that is smaller than 11. So we set the bit equal to 1 for the 8's place. But what about the empty places to the left? Well, we're going to set those to 0. Why 0? Well, remember, we're trying to convert decimal 139 to binary. If we set any of these to 1, then the binary number would end up being more than decimal 139. Okay, so we've placed a 1 bit in the 8's place because 8 was the highest value, less than 11. So now we need to subtract 8 from 11, and we get 3. What's the largest place value less than or equal to 3? Well, it's going to be the 2's place, so let's put a 1 bit there. Finally, we subtract 2 from 3 to get 1, and of course we once again ask, what is the largest place value less than or equal to 1? Well, clearly it's the 1's place, so we put a 1 bit in the 1's place. And guess what? We've converted 139 decimal to binary. It took a bit longer, but that's mainly because we're used to thinking in terms of decimal numbers rather than binary. So going from decimal to binary doesn't really come naturally, at least for most people.